Good morning and welcome to the second day of the NetPoint GPM conference. Welcome back if you tuned in yesterday. As you may know, this is where professionals and the GPM community share their experiences with GPM and GPM software. Also, our innovation team unveils new software, as Sevi will do right after this presentation. And we also introduce new innovation, our new thinking, which is about what I'm going to do today. So without any further ado, so this is a book that I read a few years back, and it was a paradigm shift. It reminded me loud and clear that foremost, we schedulers are forecasters. What do we forecast? Primarily project completion dates. We have models to do that, but at the end of the day, if you begin with the end in mind, that's what we're doing. And a couple of thoughts that the authors have that became sort of, my framework for how do we schedulers become super forecasters? Not just the most skilled schedulers, but all schedulers at some point in time can be super forecasters. And okay, so this is the first thought. Bottom line is we have to start relying on human thought principally and bring the computer and work together with algorithms run by computers and use our judgment to complement that. Just relying on our expert judgment is proven not to be good enough anymore. And what the authors say is that we have to blend computer-based forecasting and our expert judgment in the future. Now, this to me was very important, but there was another sentence in the book that just floored me. Estimating is what you do when you don't know. And I thought to myself, shoot, schedulers, that's all we do is estimate durations, figure things out in advance. How can we go from guessing to knowing? And that kind of became the mantra. This is sort of the four corners of the presentation. So I'll launch into the problem. What is it that I'm trying to solve? The project completion dates that are forecasted by our schedules are just too unpredictable. What does that mean? We have a completion date in the future and we miss it. So no matter how much money we spend in scheduling software, level of effort, most projects still finish late. Now, you don't have to take my word for it. Here's an example of a well-known scheduler from Australia. And I'll let you read that highlighted paragraph. And you notice where it ends. Most projects finish late. If you were to browse the web, you would see lots of articles documenting this fact, ways to avoid it, how to rectify it, etc. Now, I want to just quickly touch on what two super well-known researchers think. Why is it that projects finish late? The first one is that stakeholders settle on project duration without fully considering similar projects. Kahneman and Tversky figured this out decades ago. And I'll show you in a little bit that we set durations too arbitrarily most of the time, in construction planning. So this afflicts us to varying extents, depending on the team at hand. But we need to avoid this through some sort of a protocol. And then we schedulers are the eternal optimists. If we have to estimate a duration for an activity, we tend to prefer the shorter duration than the longer duration. Our brains are just coded that way. So we need to also account for this in our schedules. Here's an example of a well-known book published in 2014. And if you look in the book for how to set project duration, there is not a single comment. I've looked at many books, well-known books in scheduling. No one talks about how to set your duration. It's really a huge gap in our knowledge. Be that as it may, I think that there are two factors that are even more prevalent in why projects finish late. The first one is that we tend to rely too much on deterministic schedules. If you show me your conventional CPM schedule with a completion date of November 2024, and I was to ask you, what is the probability you'll make that date? You would have no clue. A forecast without a probability associated with it is a very weak forecast, but that's what we are. But we fixed that. In the mid-90s, we realized that we really had to know what the probability, what the likelihood was of our completion date. So we started to simulate schedules. We started to do what we call risk assessed schedules. But even when we do that, what do? Instead of one duration for an activity, we have three durations: optimistic, most likely, pessimistic. But we're still just estimating, even though as the schedule is progressing, there is knowledge developing from actualized activities. We continue to simulate the schedule every once in a while, and we still rely on estimates. We are disregarding the knowledge accumulating, what I call left of the data date. So we want to fix that too. How are we going to solve this problem? Well, what I have come to call learning project schedules that algorithmically extrapolate activity durations right at the data date, the remaining portion of the schedule, from data that is amassing in the as-built portion of the schedule, which in a scheduling parlance, left of the data date. So this is the new idea. It would appear simple enough, but the devil is in the details. So allow me to proceed. I'm going to lay some foundation so we're all on the same page. Fundamentally, a project schedule is a network model, and we know that we have activities, their dependencies or logic ties, we have milestones, start finish dates, etc. Now, most large projects, any size construction project, this is a very complex endeavor. It cannot be done manually. So, since the 1960s, in fact, we have been using software to generate schedules. And how does that work? We input the data I was just talking about, the activities, etc. And what does the software do? It generates start and finish dates for the activities, milestones, and it forecasts the date the project is supposed to complete. There we go, the forecast. And the contribution of CPM to scheduling was that the software will give us the longest path of activities controlling the completion of the project, which of course is called the critical path. Now, there are two types of project schedules based on the method the software implements to forecast project completion. On the one hand, we have deterministic schedules. What does the software do? These, by the way, would be the conventional schedules. The software, the application forecasts one project completion date and of unknown probability of occurrence. Let me hammer on this. The software gives us a completion date. We have no clue the likelihood of that date being met. And again, identifies the critical path leading from project start to project completion date. 99.999% of schedules globally are like this. And there is a multiplicity of software that you can use. On the other hand, we have stochastic schedules. In this case, the software forecasts all possible project completion dates, from the shortest project completion duration to the earliest completion date to the latest completion date. But for every particular completion date within the realm of your project, each one has a probability of being met. And we call that the p-value, the probability value. And now, instead of giving us the critical path, the software determines for us what is the probability of the activities landing on the critical path. A superior concept is just one critical path. What algorithms do software use to give us a schedule? Well, CPM, the critical path method. This is the legacy algorithm, and we all know what it does. That forward pass gives us the early dates, a backward pass gives us the late dates. The one thing about CPM, though, is the schedule is calculated in batches. You do all your input interactively, but while you're doing the input, the software is sitting idle. The algorithm is doing nothing. Once you're done with your input, you push some button of some kind, and the software, goes to work. And the thing about CPM, if you had a 10,000 activity schedule, and one activity had 100 days of float, and you increase its duration by 1 day, which is irrelevant to the schedule, you still have to push the button. The algorithm does its thing, and the entire schedule is recalculated completely. Not very efficient. On the other hand, we have GPM. By the way, CPM was first used in October 1957, so it turns 65 years this October. GPM doesn't do a forward or a backward pass. And as you are impacting your schedule, as you are stretching an activity, connecting a logic tie, the algorithm in that very time recalculates and refreshes the schedule graph only where the schedule was impacted. The first time we used GPM was on a major project in Boston. It was an eye-opener. That was actually in May or June 2007. So we have over 15 years now with GPM. Now, I talked about scheduling fallacy too. I don't mean to, pound on CPM so hard, but my sense is that the reason the schedulers disregard the left side of the schedule is because CPM cannot calculate total floats. It cannot show you the critical path left of the data date. When I started scheduling, to date myself, late 60s, early 70s, and I had a computer card tray, and we did an update, we would remove the cards for the completed activities, and the schedule would just process from the date on forward. So even to this, so that is sort of the way we started scheduling a progress schedule. And to this day, schedulers, they might get some actual dates, but they don't really spend the effort needed for it to be accurate. I'm here to tell you that a schedule, as it progresses, as the day-to-day advances, has a guessing part right at the day-to-day and a knowing part left of the day-to-day. For us schedulers, not to devote the same effort to get an accurate schedule left of the day-to-day is a huge wasted opportunity. Now, mind you, again, we fell into that habit because CPM doesn't give us floats left of the day-to-day. Well, GPM does. Every time you update your schedule, total flows in the critical path are happening left of the day-to-day. So, clearly more helpful in that respect. The thing of it is, as you update your schedule from June to July to August, total flows are changing right at the day-to-day, and so are they changing left of the day-to-day. Even though the actual start and finish days are fixed, total flows in the critical path as built can change with every update based on what is happening right at the day-to-day. It's a very dynamic schedule. What methods do we use to generate a forecast, a stochastic forecast? We can do a CPM simulation, but CPM simulations will give you unrealistic completion date probabilities, unrealistic p-values, unless you intend to do your project with all activities on the early start dates. Well, that's not realistic. A GPM can give you realistic, it can use float. You can model float use on a GPM simulation, so you can get varying kind of distributions. Here's an example quickly of a GPM simulation. The green curve on top is what the completion days on your project would be if all activities start on the early day. That's the only thing CPM can do. Notice that the P100 is basically P70 on the late curve. And because most projects finish late, what you think is P100 may only be P75. So clearly, it's a good idea to do GPM simulation going forward if you have the opportunity and you have the software. You get more reliable p-values. All right? So what is a highly predictable schedule? Basically, we're going to manage the schedule to yield consistent p-values. We're going to select a p-value and we're going to stick with it. And we're going to know that that's what it is. How do we do that? We're going to mitigate the planning fallacy, optimism bias, and a scheduling fallacy factors, one single fell swoop. I also call these learning schedules because as the data is advancing, we are learning activity durations and logic as they are actualizing left of the day-to-day. And we are using a concept that was also created by or invented by Kahneman and Tversky, what's called reference class forecasting. Allow me to spend a little time on this. Reference class forecasting, by the way, is becoming sort of a project management knowledge force. And in Europe particularly, they're really using this extensively in major programs. Basically, when Kahneman and Tversky understood that people were failing to fully considering prior projects they said, well, why don't we do that? Let's characterize our project and let's find similar projects. And by doing so, then we are superseding estimates with as-built durations. So reference class forecasting takes care of the planning fallacy and optimism bias. For instance, reference class forecasting is being used extensively to target the duration of your project. So how do we do this? First of all, you have to characterize your reference class, your project characteristics. And I'll show you that in a minute. And then once you have a reference class, then you want to get as-built and as-planned scheduled data for the projects in your reference class. 10 projects will be a minimum. People that are into this kind of forecasting, they suggest 12 to 15 projects. So let's say you found 10 projects and you know the durations of these projects, as-built durations. One project, the shortest duration, 350 days in construction, let's say, the longest project, 400 days. And in between, there's 10 projects. Well, you would sort your durations from the shortest to the longest, and then you have frequencies for each one of these, and you get a distribution curve. So, you know, the shortest project would have the least probability, and the longest project, the highest probability of it happening in that time span. Which one do you select? Because you're using as-built data, realistic distribution curves, you're not using early curves, you can select the probable p-value, which is 75% plus or minus 12%. I would say that if I pick 70% likelihood at p70, I run with that. So for most, we're using reference class forecasting to establish project duration. Now here's how do you establish your reference class. If you had a K-12 school project, well, you got so many classrooms, size classrooms, you have labs, you have sports facilities, you know, you have parking spaces, site, etc. So basically, you want to characterize your project as to all of these elements. And in your reference class, some of these can be similar, good enough, some got to be the same. For instance, climate region. If your project is northern Minnesota, you would not want in your reference class something in South Florida. It would just not be helpful to you. On the other hand, if your project starts in June of a particular year, the project started in May is similar. The weather impact is going to be similar, so you can consider that project. Now, you might be asking yourself, well, shoot, if I'm an owner doing a school once in a lifetime, how do I get this data? When you put out your RFPs for your owner's project manager, your designer, your construction manager, you can just request that they include in their proposal projects in the reference class, which you would have defined in your RFP. By the time all is said and done, you're going to get easily 2 to 3 projects per proposer. You may have more than 15. And in fact, this could be a criteria that you could use to select, to give some value, scores to the proposers. Now, learning schedule. So I set my project duration using reference class forecasting. Let's say that was 400 days. Now, I put together my base case learning schedule, which is a detailed level 3 schedule. Shall we say 5 activities to 15-day activity range by and large. But our base case schedule must finish earlier than the targeted completion date. 10% to 15% recommended range. If you were to finish right on the completion date, the p-value of your date would be single digit at best. So you're going to have to finish earlier in order to have a reasonable p-value. Once we have the schedule together, then we do a Monte Carlo simulation, a risk assessment, you gather your stakeholders, you estimate activities. And at this point in time, it's all expert judgment, it's all estimating. This is your weakest forecast at the moment, but it is supposed it shall get better. Now, a couple of things about the learning schedule. Your software ideally has the capability to automatically summarize your schedule. And I mean activity and logic, what we call density zooming. Last year, I introduced this new invention. And actually today, right after this presentation, you'll see the software, Project Summit, who does this. Because by the time we build our learning schedule, chances are there is already a level 2 schedule, strategic schedule. And of course, we want to make sure that our level 3 schedule is in sync with that. And to have to manually summarize the schedule is prohibitive. But if you have the software to do that, is you know, in a blink of an eye, you have the summary and you can confirm that activity days and flows are the same. The summaries from to the detail. And you may have to do this several times throughout your project, and clearly you need software to do that. Now, what is a reference class in a learning schedule? On a process type of facility, you know, we have 5 categories: procurement, construction, etc. When it comes to construction, they have to be the same physical scope, same crew type. You might have an activity which has to do with a concrete supported deck. So all the supported decks on your project that have the same square foot and are pretty similar, of course, same crew type, they can be in the reference class, and so on. One thing though is that you want to have about 10 plus activities in a reference class. They have the same description but for area. I mean, you may have a 50-story high-rise building in Manhattan, and you're going to have possibly, depending on the square foot, you could have a 47 or 46 or 90 exact identical floors, but the description will be the same, but the floor, the story will be different. So that is what distinguishes the activities, right? And they should have like duration. That means within 10-20%. Now, because we're going to sample from actual duration left of the data date, and we're going to use those right of the data date, it's very important for us to recognize that actual durations of like activities may have different impacts. So we have to account for that. What do I mean by this? Well, you know, if you're working on your 3rd floor, on your 30th floor, the time it takes the crew to get to your work, it is quite different. So you should be aware of that. The further out geographically activities are, the more the durations are likely to be different because of this. Weather. Same activities may have different weather impacts. So we want to account for that if we're going to use what we know to what we estimate right at the data date, and so on and so forth. These are all the factors, you know, learning curve. We know that when a crew spends 100% effort on the first activity, it'll be 90% on the second activity, perhaps 81% on the 4th activity. Every time it doubles, you know, there is an improvement, a constant improvement, how long it takes the crew to do the work. So again, we should account for this. How do we do this? Even though a reference class may have 50 activities, we're only going to sample from the prior 10. Now, mind you, further down right of the data date, further away from the data date, it's hard to predict or to consider that these impacts I talked about will be the same. However, we're going to take that knowledge that we have and use it instead of the original estimates because it is superior. All right, so how do we do the forecasting? Remember, at the onset of our project, we were 100% expert judgment duration estimates and logic. At some point in time, activities are going to be completing. Shall we say that when 15–20% of the activities are completed, you maybe do another schedule risk assessment on your learning schedule, you do another Monte Carlo simulation, primarily focused perhaps on activity variability risk. So now we want to be computing current project completion p-values. So now we're going into the phase of knowing versus estimating, and it's a gradual ascent. And so right on the data date, we're going to sample for every activity, if it is in a reference class, by using the actual durations of the prior 10 activities in the reference class. We're going to use overall durations. I call the simplified forecasting. We're not going to go to net durations. If I was going to net durations, then I would have to add those impacts right at the data date. That's an advancement that'll be coming forth, at some point in time. What about activities that are not in the reference class, just too few of them? Well, we're going to use a calibrating technique for that. How do I get this data? Well, if it's contractual activities, we have field dailies. And if schedulers are tracking progress and at the time that it's happening on a weekly basis, it's pretty easy to get accurate start dates and finish dates for your activities right off your daily field reports. But we're getting overall durations. And chances are that you wouldn't be able to get the days added by weather, working through weather, or just stopped, period. If you wanted to get net as build durations, which would be like a really robust knowledge, you would need an automatic tracking system. Now, there are some systems out there that advertise that'll give you automatic as-built data on your schedule without having to do it manually. I doubt that those systems will give you a net duration. So for the moment, we're going to focus on overall durations and see that as an improvement over estimates. Outside of construction activities, we have, submittal loss, etc. All of these records will, if you are cautious and apply it yourself, will give you accurate as-built durations. Now, what about logic? Well, in your schedule, if you have S-plan finish to start logic and you notice the software notices that the logic is actualized as start to start, and you want to consider that, then you could use as-built logic ties right at the data date and your simulation and your risk assessment. This can be an option on the software, one way or the other. What about non-reference class activities? These activities are just too few of them. But you can we'll code those to a CSI division. And we will do a ratio of actual as-built duration for the CSI division divided by estimated duration. And we can take that factor and apply it right at the data date. So we are not exactly doing reference class forecasting, but we're getting what we can out of the knowledge that we're gaining. as the project unfolds. So this is how, this is going to come down. You start your learning schedule, risk assessments, your simulations, and at the beginning of your project, your p-value was 70%, p70. As the day-to-day moves on and you run your simulation, your p-value may become next time up p72, next month, and maybe p65. You should fully expect a fluctuation in p-value. Ideally, the p-value starts to trend plus or minus 2% of your p70 original targeted p-value. One thing you're going to notice too, you remember the base case learning schedule has critical path total float, 12 to 15% of the duration. What you're going to notice on your learning schedule is this float is going to be reducing gradually without eroding targeted p-value. Because as the data is advancing, risk in the schedule is going away for the activities already completed. So as your risk is reducing, your buffer can reduce accordingly. What should happen though if your p-value starts to trend downward? We started at 70% and it fluctuated, and then it starts to trend down to 67%, 65%, 60%, 57%. Well, at some point in time, you're going to say, well, hold on, we have to crash the schedule. Now, when Kelly and Walker actually invented CPM back in 1957, that's the problem they were trying to solve. How do I crash a schedule, algorithmically using activities and logic? Well, the Kelly and Walker crashing protocol is not going to work for us because we have a completion risk schedule, not a critical path based schedule. So we have to undertake stochastic compression. What is this? Basically, you look at your current simulation with a p57, you develop time course curves, acceleration curves for high criticality index activities. And then you run successive simulations, each time crashing a cost-effective activity until you get back from p57 back to p70 or close to it. So obviously, you're going to do that with stakeholders, and it's going to be a collaborative crashing session. And when that happens, then you're good to go. We're back on track. Now, I am aware that there is a lot coming at you in this presentation, and it can be overwhelming, even for us very seasoned schedulers, or maybe you're having a lot of fun. But let me just try one more thing on you. We all know on a conventional schedule that if a delay falls off the critical path, and I'm the contractor, I don't get more time for that delay. We call this in the firm, tongue-in-cheek, the modern continental conundrum. We were on the big dig in Boston from August '89 until 2012, and there was a large contractor doing a project about $800 million a contract, and it so happens we were issuing change orders off the critical path, and the project manager would sit with my scheduler John, and he would say, John, I cannot get any time for these. I know it's off the critical path, but in my gut, you are changing my risk position. I may not make the end date, and I store that conundrum in the back of my brain for like 20 years until I figured it out. And with Dr. Vivek, my good cohort, we figured this all out. And when your schedule is managed based on completion risk, as you're learning the schedule, any delay that lowers p-value substantially increases your risk of overrunning the project. So that means that if you have a delay off the critical path and it reduces your p-value from p70 to p62, in all fairness, the contractor should be getting an extension back to a completion date that has the original p-value. And if you want to read more about this, I have a reference, AACE, a paper we wrote, Dr. Rivik and I, a few years back, and gives you a lot more detail about this. So just to close, we want to be super schedulers, scheduling super forecasters, not just the privileged ones in this audience that probably are really accomplished, but really anywhere in the globe, any scheduler with a few years of experience in the right software can be a super forecaster. And this is how we're going to do it: learning the schedules, and we're gonna use the computer progressively more so than our thinking. However, we might have to intervene if it comes that that's what we have to do. Thank you so very much for your interest, and we can take some questions.
Hi, Dr. G. I have some questions for you. So the first question is, what obstacles do you foresee in implementing this approach?
Well, obviously, you need the software, and there is so much to it that my guess is that we're going to approach it a few improvements at a time. And the investment in CPM software, it's billions annually. And so to move off legacy software to the kind of software that does this, it takes a lot of inertia. So that is, yeah, a couple I can think of.
All right, the next question. You mentioned that a scheduler's expert opinion alone has proven to be not good enough for accurately forecasting project completion. How does this premise impact the reliance upon forensic expert testimony?
Well, so forensic experts have the opportunity to do things retrospectively. So they actually have actual knowledge of what happened. So what they have to do now is to expertly figure out what caused the delay. So I think actually a forensic expert has a better start because he's got the actual as-built schedule, hopefully. Now he just to sort out what happened. And that goes down to the individual. Now, mind you, if you had a GPM schedule with an accurate as-built schedule left of the data day, you will instantaneously every month know delays, actual delays, and whether or not they were on the critical path. So you could take your CPM schedule, export it to a GPM software, and automatically get your as-built schedule, and you could see what's happening, assuming your data is accurate.
Okay. The next question is, how would schedule specifications need to change in terms of contract flow?
Well, okay, so now we're talking like 10 years, 15 years ahead of us, okay? So I'm not sure how well I can forecast all this or predict what's going to happen, but in reality, at some point in time, there's going to be a switch from critical path total flow to completion risk. That's the real determinant of our ability to complete by a certain date. So we're going to have to shift the emphasis from that to completion risk, your p-value. Anytime your p-value is impacted, you want to figure out what is the cause of that and who is responsible for it, and then you make those kinds of decisions on that basis. Clearly, we're a long ways away for this to happen. And some people that are progressive may do it themselves on a case study basis, like side by side. You know, you could have your official players using critical path total float conventional schedules. You could have an alter ego team doing a completion risk as a study, right? And then you can sort of figure out how they compare. Probably that's what's going to have to happen. Do parallel until you can drop off the legacy case and go with the new scenario.
Okay, another question. How would a scheduler's role change if using RCF?
Well, first of all, you know, I mean, I'm almost certain that we have multiple accomplished schedulers in the audience today. And for those schedulers that have that skill set, you know, they probably have apply some rigor to the project duration. But in most cases, you come into the scene and duration's been set. So we already in Europe, they're doing it. And you're gonna have to spec this in your specification. You're gonna have to put this in your request for proposals and textbooks. I mean, it is astonishing to me, and that every scheduling textbook that I looked at in the last week, there's nary a reference as to how to set your duration. So our chief knowledge officer, by the way, which I will not name necessarily, he just took a reference class, forecasting class from the Oxford project and the Oxford School in London. So he's been certified as a reference class forecaster. So I suggest that if you haven't, you start jumping on it.
The next question is, how large of a project does this approach start to provide for the return on investment on the extra data gathering effort it needs?
Well, I mean, I would say it's not so much how large the project, but how crucial you forecast is that it be met. If there's a lot of writing on let me take that back a little bit. If you have a project that is in the US $250 million and beyond, I mean, this is going to pay for itself. Now, a smaller project, if you have a really urgent completion date, especially if you have an accelerated project. Let's say you got to get things done. Let's talk about, you know, a new vaccine, and you got to build a facility for it, and you're in a super hurry. It may only be 50 million, but you want to make sure that your forecast is steady. It'll pay for itself. Now, mind you, right now, first of all, we are probably, even a PMA, we are 2 to 3 years away from the software that we can start to do this. Okay, so this is not like around the corner at this point. I suppose that if you were really interested in this, you could case study, pilot anything you want. If you want for money at it, so to speak, you know, you could pilot study any project you want and learn from that, right? And I suspect we'll be doing that, you know, along the way.
All right, the next question. Most scheduling texts don't seem to talk much about project completion and instead focus on the details of scheduling. Why do you think that is?
It's the tail wagging the dog. That's simple as that. You know, we schedulers are fascinated with the mechanics of the schedule. You know what? Mind you, okay, so let me just make sure. To have an accurate completion forecast, you better have a damn good schedule. So you have to have enough effort on a good schedule. But we got so caught up on the schedule itself that we forgot that we were forecasters. And we lost sight of beginning with the end in mind. Now, when we do simulation risk assessment, actually those schedulers are right on the project completion forecast because you're getting a distribution curve, right? But if you're not doing risk assessments, then yeah, we're sort of not spending enough time on that. You know, how we got there? When I started scheduling, 1969, around a drawing board with a superintendent, project managers, and we got everything laid out. Then I had to go put the software, come back with the completion date. And I met with my team. The first two questions they asked me was, what's the completion date? What's the critical path? They couldn't give a hoot about the activity start days or anything. That's all they wanted to know. If they got the right date, they were happy. So some along the way, the stakeholder got delinked from the product, from the tool. And that's how you lose track.
So if the model is using as-built data, does the Monte Carlo simulation use a normal distribution? And can you choose a different one, like a PERT distribution, to put more emphasis on most likely?
Okay, so the idea is for reference class activities, you're going to replace any distribution you had by sampling from the actual distributions. So if you had 2,000 activities, right of the data that is simulation, 2,000 activities, maybe 1,500 of them, you are sampling from as-built distributions. The other 500, you'll be using whatever assumed function you want still until they get superseded by actual distributions.
Okay, we have one last question. Should scheduling companies shift their focus to hiring data analysts or computer scientists versus construction engineers?
Oh, absolutely not. I suspect that a team is the best answer to that, because in reality, you're gonna have. I mean, you can be a little good at everything, but not really good at everything. So, I mean, probably a team. I mean, some of our schedulers are just, crackerjackers when it comes to data. Some are not. Some more into the, what goes to the schedule for it to be realistic. So, I think you probably need a little of both.
All right, thank you so much, Dr. Gee. That's lots of our questions.
Thank you all for your interest.